Pennsylvania. First time here.
Well, that's quite a number of new people. I think James. Go ahead.
Joe Riggins of Ithaca, New York. First time as a member, and I really appreciate the online here because I don't know that I'll ever get out your way.
Okay, great. I see our participants tonight are pretty high compared to what they've been in the last couple of months. It must be due to James and a lot of interest in his topic. Well, if there's no one new that wants to introduce themselves, let's spend a couple of minutes on something we've got in the museum.
Hey, Steve,
yeah.
Quick, from the Golden State of California, I got into the tail end of this thing at the beginning. Did you say you're just tentatively planning for the conference, but you want to wait till see what the COVID results are?
That's exactly right. We will probably
okay,
wait
that's all I needed, yeah.
As long as possible to make a decision to see what's going on.
Great, thanks, Steve.
Yep. Okay, well, let's go. Let's see if we can turn Larry on. And we're going to look at the CBS Rx 4041 color adapter. As soon as Larry gets over in position. Yeah, there it is. This is an interesting gadget. It was made in 1950. There aren't very many of them around. In fact, I know of only one other, and I'm not sure it is more complete than this one was. There are two parts to this. The RX-40 is the wheel assembly, which is on the front here, and the RX-41 is the adapter, which is the box behind it. Larry, if you can, there you go. There's the RX-41. And inside, go back to the wheel now. We got this thing very incomplete years ago. No color wheel, missing, and I'll talk more about the RX-41 in a minute after I talk about the color, the RX-40. The RX-40 was missing its wheel, and a bunch of other stuff. What's in there is about a color wheel with 6 segments in it, about the size of the housing is about the size of the wheel, and there's a motor in the center of it, and then a sensor on it, and then the sort of standard circuitry that was used back then to synchronize the wheel to the vertical scanning. It has a reactance transformer that slows down the motor to make it to the point where it syncs with the vertical sync. And you can see on the front of it, it's got an on-off switch, actually a 2-position switch. In one position is sort of like it bypasses the control circuitry, so it runs at full speed. The other position is the run position, where the control circuitry is enabled. And the push button is for phasing. This does not have automatic phasing like the Grid Research Monitor has. You have to push the button. They're one of 3 possibilities for color phase, and you push it until you get the right phase. Now, this was mounted in front of a RCA 9T246, just standard black and white set of the era, and was converted to connected to the set using the RX-41 box in the back. The problem with using a black and white set for the CBS standard was the horizontal scanning frequency. Black and white is 15,750, and the CBS system was 29,000 and something. I don't remember the exact number. So the horizontal scanning circuits, the yoke and the flyback and everything else, did not work well at that high rate. So what they did was they built this in the little box in the back. They put a separate flyback in. There's a switch in there to switch between black and white and color. And in the color position, it reduces the size of the scan by about an inch on each side. I guess so it'll fit within the wheel that they've got. The vertical rate is not too difficult because when you put it in the color mode, all it does is change the rate from 60 hertz to 44 hertz, which is within the range of all the components in a set like that. So they didn't have to do much with the vertical output, the vertical scanning. It was the horizontal that was the mess. When we got this, the RX41, it was missing the most important ingredient, which is the flyback. And obviously, we weren't able to get the original CBS part. Should mention that this thing was really well documented, as all the CBS color stuff was. All kinds of, even diagrams of how the flybacks were made. But that wasn't an option for us. So we had to experiment. And we finally discovered that we tried a standard flyback from that era. And we only got about, at that frequency, we only got about 6 kilovolts out of the high voltage rectifier. So we finally ended up with a Fly 4, which is a voltage doubler. I don't know what set it was used in, but the early, very early RCA sets and some others. And it turned out that it gave us 10 kilovolts of high voltage, and produced a picture that had a pretty decent linearity. There's still some defects in it over on the far left side. It's not perfectly linear, but it worked pretty well, much better than the first flyback that we attempted. Now, so we had it, but the only problem was that when it was operating, it was over scanning. So we had to reduce the level of the signal going to the yoke, add some components to accomplish that. That all worked. Now, the way this thing is connected, Larry is showing you the back of it. There's a cable that comes out of the back. Actually, there are a couple of them, but there's the main cable, and it goes to a couple of tube socket adapters, like you use for testing a tube in place. One of them was the horizontal output tube, because you didn't use the RX41 has its own horizontal output tube, so you didn't use the one in the TV set in the color mode. It's also one of these adapters that went under the horizontal oscillator, and another one that went under the vertical oscillator and output tube. So you just pull the tube out, plug this adapter in, and plug the tube back in. Now that whole wiring harness was missing, but again, CBS provided beautiful documentation, and we were able to get it working. So, and then Cliff Benham came out and made us a wheel, and got it balanced. So it works pretty darn well. It produces a nice picture. Oh, any questions on this gadget?
Steve, can you tell me what that sold for then?
Oh, I have no idea. I'm not sure it ever sold.
Okay.
Any chance you could make it work here?
I don't think so. It hasn't been turned on in so long. I don't even think the video feed to it is there.
I guess I'm gonna have to reboot. Yeah, it's flashing all over. I can't go with that.
When it gets back to when I get back to Ohio, that I will be firing up all these things that have been sitting idle all this time, and we'll have it. We'll be able to show it. One more thing I should mention. Notice that the rack at the bottom, that brown. There you go. It was also missing. This thing slides out of the way for black and white. So there was a rack that on ball bearings that would move the whole assembly out of the way when you were watching black and white, and then when you're watching color, you'd push it back in place. This is not the original. We had to fabricate one out of some some parts for a,
Put the computer to sleep and woke it back up.
and,
It didn't reboot.
okay. And I think that's parts out of a window assembly or something. I can't remember. I think I found it at Lowe's or Home Depot. Any other questions?
Steve,
Yeah.
wasn't the frame rate and the number of scan lines different on the CBS color system?
Yes, it was. The frame rate was 144 per second. The field rate was 1/3 of that for each color. And the horizontal scan rate was 29,000 some hertz compared to 15,750 for black and white.
How many scan lines on the CBS color system?
441.
Okay, thank you.
Actually, 405 lines because
Thank you for correcting me. And the resolution was relatively limited. One of the things on our website, there's some pictures taken off the screen, and you can see when there's lettering there, it's not great. That was one of the many limitations of the CBS system, and it would have been really bad on larger screen. You know, all the equipment that was made back in 1950 was 10 or 12-inch screen sizes, where these defects didn't show up. You get to a size screen we have today, it would have been a nightmare.
Dave, what are you using for test equipment or signal source?
Well, Daryl Hawk makes the Aurora standards converter, and he sells this, and its primary market is in England for 625 to 405 line conversion. And at various, we have a bunch of those in the museum for one thing or another. And then, but anytime I had a specialized need like this, I said, hey, Daryl, can you make us a converter? And he says, of course. And that's one of them that he made. Another one that he made was, we have an early 1952 RCA prototype, pre-NTSC, that used a completely different system. And Daryl built a converter for that too. So that's how we run it. Okay, if there are no more questions, then can we get James up? I heard him in the background having some issues with his computer. I don't know if those are resolved.
James, your microphone is muted right now, if you haven't noticed. James and I were talking earlier, and it's always something.
You should make a sign that says you are muted.
Where's the technical difficulties slide?
It's like putting up the off the air cue card when you're off the air.
While we're at a pause, let me invite Tim from Dallas to come to Kilgore and see the Texas Broadcast Museum. Just a cheap promotional announcement.
I have been to that museum twice, but that was
you have? Okay.
That was before the remodeling and the freeze and all that kind of stuff, naturally. So yeah, it was several years ago, but I was there twice.
You're probably thinking of the one that was in Dallas in Irving.
No, it was Kilgore.
Before remodeling, because
well, rearranging is what I should say.
Well, we rearrange it all the time. That's because more crap keeps coming in the door, and we don't know what to do with it. So, need to come again then.
Sure.
Get involved. We'd be happy. We're always looking for volunteers too. So, people who like to fix this stuff.
Well, I wish it wasn't such a 2-hour drive or something like that.
Yeah, well, it's a 2-hour drive. It's just the way it is. You know, I had somebody ask, why isn't this in Los Angeles? And I said, well, I don't live there for a starter. You know, that has something to do with it.
Hey, a 2-hour drive is nothing for some of us.
You know, when I lived in Dallas, it was almost a 2-hour drive to work, and it was in Dallas and I was in Dallas. You know, when I first got 30 years ago, it was a 15-minute drive, but later it got a lot longer.
Tim, what part of Dallas do you live in?
Well, actually, I live in Plano.
Oh, okay. I live in Dallas.
The first time I was at the museum was a field trip for the local Vintage Radio and Photograph Society here.
Oh, okay.
We did a field trip out there, and it was so interesting. I said, "Well, I gotta show my sister about this."
You did that was in our early days. They've been out a couple of times, at least some of the people, and they've been good supporters too. So we appreciate that.
Yeah, it's been a while.
You know, need to come back. There's all kinds of stuff you wouldn't. It boggles my mind every time I go in the place. I go, I didn't know we had one of those. People keep bringing stuff. We've got an 8,500 square foot building down the street for stuff we don't know what to do with, and it's getting rather full, which is very, very scary. We're not getting another building. That's completely out of the question. So we're going to have to be more selective.
Say, Chuck, I'd like to thank you for a wonderful tour. I came after Thanksgiving and you showed me around, and I was amazed at that museum. I'm going to come back again next Thanksgiving.
Please do. We're always welcome to have you. We were really busy today. I must admit, I'm pushed. We had a whole ton of visitors, large gaggles of families and things with lots of little kids and things. And little kids like it, which is the amazing thing. They really have a good time. So. But it takes some special attention, and all of a sudden, after a gaggle of little kids come in, it's like, okay, so what's not working now? What button did they push? What knob did they turn? It's like an Easter egg hunt trying to figure out why nothing's working right now. I'm sure you can relate, because they love buttons.
It doesn't stop when you're a kid.
No, of course not. We have adults that screw stuff up too. So, you know, I haven't found anybody actually digging into the electronics yet, but I'm expecting to find, you know, a camera opened up and somebody in there with a tweak tool playing with it or something. Wouldn't
Back at
surprise
RCA,
me.
we called that pot drift.
What kind of drift?
Pot drift.
Oh, okay. Yeah, right.
Engineers would set up a camera for a show or something like that, and we'd come back and it was different. And we'd learn that one of the managers had been adjusting.
Oh, yeah, that'll do it. It's just like in radio where the program director decides to adjust the audio processing, and all of a sudden the thing sounds like pressed duck shit or something. And you know.
Yeah, Chuck,
I have
I know
no
what
idea
you
how it
mean.
happened. No, I know nothing, you know, and it's just the way it is.
Yeah, having a little kid in the house, I'll go to turn on an old set and like, where'd the picture go? Why is it? Oh, someone turned the brightness all the way down.
Yeah, that'll do it every
Give me
time.
a heart
won't it?
attack.
You know, it really does. You know, it's like, okay, but sometimes it's you know, it's a real challenge to figure out which button they turned or whatever. But we let kids and we let adults crawl all over the stuff too. So maybe we're foolish, but people seem to like that. So. Anyway, come see us. I didn't mean to hog the meeting or anything. I'm sitting here eating chips because I'm starving to death because I didn't get to eat lunch today because we were that busy. So.
Oh, Chuck.
Yeah.
I was cleaning out some clothes up there in my bedroom here the other day, and I found one of your T-shirts my next door neighbor brought me.
Oh, really?
He takes his RV down there to Texas all the time. He said, "Oh, I got a surprise for you." And if I'd thought about it, I would have worn it tonight.
Yeah, well, that would be cool. I got one on right now. You know, I'm still in costume for the day. You know, I didn't change especially for this Zoom meeting.
Oh, you look fine.
Well, if I don't pass out beforehand. Yeah.
Speaking of, we don't know what to do with stuff. I just acquired a portable 2-inch Do you have one of those down there?
No, I don't. We'd like to have one, actually.
Yeah, it's yours. I'll send you pictures. It's a Ampex portable 2-inch, but I also have a couple of portable 1-inches that one of our old directors had, and he was liquidating his production company. It's been sitting in the basement for a couple of years.
Those things, when you lug them in, will make one arm longer than the other. I can guarantee you that. They were definitely gravitationally enhanced. I mean, I can't believe people carried around a 1-inch machine, for ENG use or something, but they did all the time until 3/4 came out. We've got a really cool 1-inch portable that Nagra made for Ampex. I mean, it's beautiful. I mean, if you've ever seen a Nagra tape recorder, that it's Swiss made and it's built like a watch, really. And that one wouldn't be too bad to carry around, but still, that would be quite a challenge still. But the 2-inch machines, I passed one up about 30 years ago, and I should have bought it, and I didn't. And love to have a portable 2-inch machine.
Hey, Steve, we can start now.
Okay, I will mute myself.
Yeah, all right.
Am I waiting a cue from someone?
I thought Steve was going to cue you, but yeah, we
Okay.
can start anytime you're ready now, James.
You're cued.
Okay, I'm on. I don't see myself up there, but I see Steve, but I'll take your word for it. Yeah, for those who don't know me, I'm James O'Neill, and here in beautiful Alexandria, Virginia, a little bit cold out there like it is where a lot of you are. Gratified we've got such a big audience tonight. And I'm going to be talking about something that it seems has gotten to be such an arcane subject. Very few people know much about it, especially the younger generation. And I'll tell you the genesis of this presentation. A few years ago, I was at a professional society, broadcast engineering people, and it was a luncheon meeting. And before the business started, we were having lunch and just sitting around over coffee. And I was talking, some of the conversation at our table drifted to Kinescope recording. Well, I have a little bit of experience in kinescoping, I'll tell you about. And I was talking about some of the problems in obtaining a good quality kinescope. And I was going on at some length. And finally, there was a younger member of the same group standing behind me. I did not know this. And finally, he blurted out, "Why in hell didn't they just videotape it?" So I had to explain there was no videotape until 1956 and thereafter. So this got me thinking, gee, since I'm probably one of the last people still standing, I'm not bragging, somebody else probably has bragging rights too, that had any association with Kinescope recording, maybe I better put some of this down. Maybe I better offload this on other people. And I'll tell you my involvement. I was never an operator. I did do maintenance. I was hired to do maintenance by the U.S. agency's Television and Film Service in 1975. And when I got there, we had 3 Kinescope machines running pretty much full time. This was before we got into satellite distribution of our programming. And some of the people referred to the Kinney room as our transmitter building, because this is how we connected with the outside world. If a country, we were sending programming around the world, and if a country could not play a 52560 color or black and white tape, i.e. a 62550 country or something like that, we sent them 16 millimeter Kinescope recordings, either black and white or color. We had 2 black and white machines and 1 color machine. Well, let's say I never operated the machines, but I was called upon to maintain them. And I had to have a pretty good working knowledge, working relationship with the ins and outs of the Kinescope recorder. So I'm going to tell you tonight a little bit about what I remember. Some of it may be fuzzy. If somebody wants to correct me, please do so. I don't claim to remember everything after almost 50 years about kinescoping. And actually, I'm one of the reasons that the Kinescope department went into oblivion. Actually, it persisted well into the 1980s, believe it or not, very close to 1990. I was promoted into management in 1984. And one of my early projects was to do a study to see what it would take to build an electronic standards conversion plant. So we didn't have to send out film anymore. We could send out videotapes in CCAM and PAL or NTSC and cover virtually all of the bases. We did not do PAL M for Brazil, but we could do everything other than PAL M. That's the only country that used that particular standard. So anyway, I designed and had built the conversion room, and this really obviated the need to do Kinescope recording, but we had a department head who we behind his back, of course, very, very nice. He was a nice guy. We called him Mr. Kinney. He just could not let go of the Kinney concept. And even as the conversion was being built, he acquired another secondhand color Kinney machine. But I won't go into all of that. So let me start the presentation. I got to punch the right button down here, click the right. Yeah. Well, my mouse is not, okay, there we go. And is this is the final. Okay. Okay. Bear with me just 1 minute. I've got to set this thing up. We didn't go full screen. Please bear with me. We're not going full. Okay, slight glitch here. We can
Jim, go up first.
Yeah,
up, further up, to the right, to the right, to the right.
Yeah,
go right.
To the right.
Go up all the way to the right, to the right. Now, all stay up there. You
Okay.
see that diskette sign up there, the little disc. You see that up there? Go up where it says autosave and off.
Yes.
Go to the right of off, to the right,
Okay.
further right,
Further
and the
right.
next one after the disc sign.
Okay, got it.
This is the one.
Okay,
Go-
from the
go ahead.
beginning. Okay, now I'm still seeing my preview. You're seeing my preview?
Still
Try
seeing the
alt
preview.
tabbing, James. Alt tab over to the PowerPoint.
Okay, let me do that. Alt tab.
Now press the button or F5.
Click F5. Okay. It's hard to see here in this light.
Yep.
No, we're not getting it. Let me try one more thing.
Oh,
Let me quit sharing. Okay, we're going to try again. Sorry about this delay, folks. We rehearsed this. Everything was all ready, and best laid plans. Well, okay, let me try one more thing. My wife is standing by. She does this every day. She's been teaching using Zoom since the pandemic started.
Actually, we can see this pretty well.
Okay, just not, I didn't want to show you my preview, but I'll go ahead and do that. Let's get this thing started. So as I say, the whole premise here is why in hell didn't they videotape? Well, didn't have videotape. But back in the beginning in television, there was light. There was lots of light in the studio. There had to be. But once the show ended, the cameras were turned off. The lights were turned off. It got very dark. This very profound darkness. And by its very nature, broadcasting, be it radio or be it television, is a very ephemeral thing. It's there for 1 second, it's gone the next. I think Garrison Keillor, one of my favorites here, probably captured it better than anyone else. This is about a radio broadcast, but it could apply to television. I'll let you read that. But basically, it was a live broadcast, first time from the station. You had a crowd there, 40 people. They had seen this thing, but what had happened exactly? They'd seen a show, went out invisibly, far as Anoka, Stillwater, Hastings. It was a miracle, but how could you know it was true? It was gone. It was gone forever. So since day one, we've been trying to get to this point in television, which we did in 1956. But the period I'm going to talk about was before Ampex, and they're bursting on the scene there at the trade show in Chicago, the NAR TV show in April of '56, with their very miraculous VR 1000. Actually, you look at the goal for preserving video goes back to 1927. This is the cover of the June 1927 Radio Electronics magazine. Cover story, you've got John Logie Baird there, supposedly. You got this artist idolized view of a video disc player, early DVD, 78 RPM phonograph disc and a projector, and he's watching a prize fight. I don't have any pictures of this, but maybe you've heard Don McLean speak or read his book, Restoring Baird's Image. He found some of these discs and restored the pictures on them, leave a lot to be desired. They're only 25 or 30 line pictures. The time-based stability of the record player was not that great, the recorder. You look at the physics of the thing too, about the best you can possibly do in frequency response on a shellac record is maybe 6-7 kilohertz on the upper end. So you're not going to get much beyond beyond video there in the 20-30 line range. And of course, when modern television started, you needed something appreciably better than that. So somebody had the idea, why not just stick a movie camera in front of a cathode ray tube? Well, in principle, it works pretty good. Kinescoping 101, I call it. What could go wrong? You've got 35, 16 millimeter film moving here, and you've got a CRT over here, a lens to focus the light on the screen, and away we go. But just not quite that simple because of some math. Movies, long time before television, went electronic. It locked into 24 frames a second. In this country, we locked into 30 frames a second, 60 cycle fields, 30 frame per second frames. And here we go, 3 and the 2 won't go. So we got to do something to solve this problem. A couple of solutions, 3 of them that come to mind. You could speed the film camera up to 30 frames per second. You could employ a skip field recording, which I'll talk about, or somehow do a conversion to fit the 2 television frames to capture them on the 1 frame of film, which is certainly not in time with the 1/30th of a second television frame. So looking at the idea of speeding the camera up to 30 frames per second to match television, actually that was considered, but you've got advantages, as you can read there. You've got a perfect 1-to-1 compatibility. 1 frame equals 1 frame when they're going the same rate. You're not losing anything. But the disadvantage is the incompatibility problems. You've got to have a special projector to do this, or maybe a projector that could operate at both 24 frames per second and 30 frames per second at the TV station. And if you've ever worked in radio, you're going to have some operator confusion. Somebody tracks an album at 33 1/3, forgets to reset the speed on the turntable. They put on a 45, you know what happens. I'm sure you've heard that, you've done it. So operator confusion would prevail. And also the increased cost of this thing. We're looking at operating cost, everything going up at least 1 1/4 times. Storage, buying the film stock, processing it, shipping it around. So not probably the best solution. Another solution that would work, you could just blank out with a shutter in the camera, mechanical shutter, or using blanking circuitry, eliminate one of the fields, capture every other field on the film frame, and it's going to be compatible. The big disadvantage there, though, you're going to lose a heck of a lot of information. You're dropping 36 TV fields every second. So only 40% of your information is being captured on the film. Not really the best thing to do. So the most logical way to do this is conversion of these frame rates. Now today, with the solid state memory we've got, the field programmable logic arrays, we mentioned, actually Steve mentioned the small standards conversion package, which is being produced. I'm sure some others of you could do this just as well with the electronics we have. But back in the late 40s, when television was getting started, this did not exist. Everything was very much a vacuum tube world and very bulky, and there was no digital. So the only way they did it, they did the same thing they did to project 24 frame per second film into a 30 frame per second television system. They did some mechanical standards conversion. So you can do the same thing here. So the advantages, you can read, completely compatible. There's no chance of operator error. Minimal loss of information. You're getting about everything except for 20%. You're losing 12 frames. I'm going to explain why. The disadvantages, you've got somewhat complicated mechanical and electronics to deal with. So you need to exercise a lot of care and setup in the operation to obtain the best quality Kinescope recordings. Little math here, just looking at a common denominator, if you will. Again, film's going by 1/24th of a second. That's the film frame rate. You can work that out. No, 5 1/20ths, television 1/30th of a second, or 4 1/20ths. 5 minus 4 equals 1. So if you drop every fifth frame, you blank it out, you're going to achieve parity. Everything fits. So that's exactly what these mechanical geniuses did back in the late 40s. And there were several of them. This is a drawing I did just to give you a little bit better idea what's going on here. And when I'm not in full field, my mouse does not work. So I'll try to explain here. If you look at the first frame on the left, the mouse is not working. I need to go full frame before the mouse is going to work my drawings here. Anyway, you've got your odd field. You're beginning with your scan with your 135 lines. Okay, no, and you're going to capture that in the 1/24th of the same frame, a 1/24th of a second frame. You're going to capture the even field. Then television's already started while the camera is in blanking. The film frame is being pulled down. The film is being pulled down for the next frame. So you're going to lose the first half of your odd field. When the camera unblanks, you are going to capture the second half of your odd field. You got all of the even field. Same thing here in reverse. You capture the first half of the odd field. Again, the camera shutter comes up. We go into blanking. The film is pulled down, and you lose the other half of your odd field. Things reversed here. You're getting both fields, and so on and so forth. There's a definite cadence there. You are losing information, but when you do this, you can achieve compatibility between film and television. Another way of looking at it, basically the same thing I said. I know sometimes it's a little easier to visualize something vertically rather than horizontally. And also, I apologize for this. I thought I had a good CAD drawing of this. I did not. I did a pen and paper drawing just before this thing started, showing graphically what the shutter of the camera looks like. It's not a magic eye tube. It's an actual shutter, an idealized shutter in a camera made for television Kinescope recording. The shutter is closed for 72 degrees or 1/20th of a second. It's open for 288 degrees or 1/30th of a second to do the television frame capture. So you add these things up, 1/30th, 1/20th, you get, I hope you get 24 frames per second. Yeah, it works. So a few limiting factors above and beyond the problems with this conversion and losing some of the picture. This is why it was so darned hard to get a good Kinescope. You lose information, as I mentioned, by virtue of the difference in frame rates. You're throwing away some of your television scan. You've got optical distortion caused by the slightly curved CRT faceplate. I don't care what they say, especially back in the late 40s, nobody could make a cathode ray tube with a perfectly flat faceplate. So that's a little bit of distortion. You've got your normal distortions, which are prevalent in a camera lens, any camera lens, especially from that period. The way they designed lenses then, tried and true, it was called ray tracing. We have computer technology, which results in much better lenses. We would not have high definition, especially UHD, ultra high definition television, if we didn't have these computer designed lenses. But the lenses are going to, show astigmatism, barrel, pincushion distortions, I mentioned here in the slide, spherical aberration, astigmatism, all sorts of optical distortions. You've got linearity scans, unless the sweeps are set perfectly in this monitor that the camera is scanning, you're not going to have an exactly geometrically correct picture. The electron beam isn't always a perfectly round dot, so you're going to have some smear there as we're scanning across the phosphor. You've got internal reflections in both the lens and the CRT faceplate, which scatter light. And there are a couple of things here you don't really think about when you're just watching television on a cathode ray tube. No matter how fine the phosphor powder is ground, it is a granular material. There's some granularity there. And the same thing with the emulsion on the film. It is a granular thing. They're the granules of a silver halide deposited on a substrate. So what the result of these two granularities are, the fact that it looks like noise. This puts a pseudo noise in the picture. This limits the signal to noise ratio. or how good the picture looks without noise moving through it. Also, I'm not going to go too much into this CRT phosphor decay time. No phosphor known to anybody stops emitting light instantly after it's stopped being hit by an electron beam. There's a little bit of an afterglow. And the phosphor that was used in most of the Kines was a P11 phosphor. It puts out light in the violet blue region. I'll explain why that was done later on. Also, it has a very short decay time, but it doesn't cut off infinitely quick. It's like a filter. You've got some skirts on the filter, so you've got a trail. You had to be very careful there, or these joinings of these half frames I mentioned, you're going to see a difference in illumination level, and it's going to stick out. You're going to have a horizontal bar moving through the picture if you're not really careful. And of course, another problem here, when you take a picture of a picture, invariably, no matter how good you light the thing, how flat the lighting is, you pick up some contrast. So this is going to distort the grayscale in the image. You're going to build up contrast, and you really don't want to do this. But that's just comes with the turf when you're doing Kinescope recordings. And there's a double dose here, double whammy, if you will. You're playing this thing back into a telecine, a film chain. You've got a television camera there with a lens. You've got glass. You're going to get the same sort of optical distortion. So this really enhances anything that's bad with a Kinescope when you project it into a television system. So just for comparison, I said about the best Kinescope that I think anybody could do, 38, maybe stretching at 40 dB if the operator is really good and everything was set up exactly by the book. Now, just for comparison, Norelco's PC70 color camera, which was sort of a game changer there, getting away from big image orthocon tubes, going to plumicons with a much lower dark current. This is right out of the Norelco specification for that camera, not less than 48 dB peak-to-peak signal to noise, or signal to RMS noise over a 4.2 megahertz bandwidth. So you got 48 dB, 38 dB, that's 10 times difference. Even the videotape machine, this is a fairly late model Ampex quad. I use this because I went to school on that machine at the factory. I still have the book. Ampex was speccing for a 525 system, 46 dB signal to noise. So the best Kine you're going to see is going to be quite a bit below that in terms of signal to noise, which is a limiting factor in a television image. Additional negative factors here. You're pulling down that film. I showed that in the chart. You've got 72 degrees when of rotation of the shutter when there's no light passing to. You've got to pull the film down. That works out to 1/20th of a second, or 8 1/3 milliseconds. Now, friends, that is really hauling you know what to pull that film down that fast with the claws or to use sprockets. Yeah, we did see a lot of film damage there because of this very fast pull down. It's not just pulling the film down, it's actually getting it stable there lined up there before the blade comes out of blanking. So you've got a nice stable piece of film to do the next scan on for the next field or partial fields and fields. So the film, the motion has to stop. Again, this is happening very fast. So that film is really being accelerated very hard on the film. Also with kinescoping, you've got to process the film. That takes time. You could put a machine. We had a couple of Kodak Viscomat processors. They could produce a processed and dry film in less than 2 minutes. These were backed up with our two black and white Kinescope machines. But then you've got your chemicals you've got to take care of. You had to mix chemistry. You've got film stock. You have to load. You have to have a dark room to do the loading. And once you've got your Kine out of the processor, there's no reuse like magnetic tape. So it's a very, very expensive process. But again, before videotape, before Ampex, there was no other way to capture television. A lot of people made television film recorders, Kinescopes, or Kine machines, as we call them. Here's one Marconi. The Brits did not use the term Kinescope recording. They called it tele-recording or television recording. Dumont, I'm going to show you something here. They called it television transcriptions. So everybody had their own name for it. And just about everybody who was big in the business one time or another made a machine. Here's an early RCA machine. It's without the film camera there. I'll show you a picture with a couple of these with the film cameras in place. Here's the General Precision Lab machine. A number of these were sold, all self-contained. See the hooded enclosure for the cathode ray tube and the special camera, this fast pull down camera with a special shutter. And here's a GPL machine teamed up. There's a tube there. I wish I had this cursor. You see the connecting piece of pipe there between the two machines. That is a light tight path for the film to come out of the camera and go right into the processor. And it comes out again in a matter of a minute or two, minute and a half, maybe, all dry and ready to be taken down and projected. That's why sometimes these skinnies are referred to as hot kinnies. They're right out of the processor, dried with some heat there so the film wouldn't stick together. Kodak, of course, they made the raw stock for this. Kodak, DuPont made film for kinescoping, several others. They made a special camera. Let's work both sides of the street, what the people up in Rochester apparently decided. What I've heard, it was a good camera. I never worked with one of these. Here's the camera open. Something sort of interesting about it, and I've lost, there we go. You have a coaxial film reels. The supply and take up are on the same shaft here, the same axis. So it made a little bit smaller profile than if you had these magazines on either side. Now this is a 1200 foot magazine. If you do the runtime, 24 frames a second, that 1200 feet will give you just about 33 minutes of runtime, which was adequate for a 30-minute show. And if you're going to do an hour show or longer, you had to have multiple Kinney recorders or you're going to miss something. This was my opening slide. I show you here, there are two homebrew Kinescope machines built around the Kodak camera, the Eastman camera. There's one back here mostly hidden by the one in front, but you see the lens is shooting into this rack over here. Here you can see the CRT in that rack, identical, I'm sure. This is a little bit bigger CRT than I normally see. It looks like it might be a 10-inch. The ones I'm familiar with were 5-inch, except in the color Kinney. And these things are not exactly stable. It's something you really wanted. If you go back and look at these other machines, you see the rails or the big massive base, the camera and the CRT display are mounted on. There's the RCA and here's the Marconi. Big heavy rails, because you're trying to minimize any sort of vibration. You're going to see that if you've got vibration. So this would be less than ideal. You've got some sort of a 3-axis arrangement here to line the camera up, but there's no physical connection between the camera and the display. So moving on, this is something I wanted to show. I'm not sure Dumont ever built a television Kinescope system, but this is a document I found in some Dumont papers. It's dated October 1947, and it shows the same sort of timing diagrams I mentioned, and it says television transcription camera. Now, I mentioned that was Dumont's cute little name for Kinescope recording, television transcription. Okay, let's look at what it costs to do Kinescope. This is just really horrific. 1,200 feet, as I said, of film gives you about 33 minutes of runtime. And nobody today is producing Kinescope film, black and white Kinescope film. But I went on the line with B&H Photo in New York. You can get a roll of Kodak black and white movie stock. This is a negative film, 72-22 for $190. They did not have anything listed beyond 400 feet. So you need 3 rolls of this, 3 times that, $570 for half an hour of film without processing. Now, I found a couple of places online that still process movie film. If you want the standard turnaround, that's 5 to 7 days. That's going to cost you $140 for the 400 footer, or $420 for the whole 1,200 feet. If you want it rushed, in other words, you want it back the same day, the cost goes up appreciably. So in 2022, cost of 30 minutes of black and white film and processing, $1,000 if you're willing to wait a few days, or if you want a rush job, over $1,300. So, you know, you can't help but think why there's no more Kinney. but it was very big. It had to be big at one time to sustain the television industry as it grew. Early on, there was no direct connection network-wise. AT&T long lines had not connected to West Coast or even that many cities, as television was starting after World War II in a big way. So the only way to do time delay for the West Coast, 3-hour difference, was on Kinney. And all 3 networks that were operating in Los Angeles had Kinescope operations, big Kinescope operations. Here you see 2 of these early RCA Kinneys I showed you with the cameras in place. It looks like this is another Kinney. These two jobbies here with the film reel, they are not. Those are sound recorders. NBC, the others, basically stuck with a double system. In other words, sound was recorded on a separate reel. It facilitated editing. It gave you better quality sound. I'm not going to take time to explain that. But I've got some statistics. Back before videotape, NBC alone in Hollywood was burning through 1.5 million linear feet of film a month in their Kinescope operation. And I'm sure the other networks were consuming an equally large amount of film. I found another reference there that said in a given month, these 3 networks operating in Los Angeles doing time delay with kinescoping, they consumed more film in this given month than all of the studios producing movies in Hollywood. So that gives you an idea of how fantastically expensive Kinescope was, but it was a necessary business tool. Now, my involvement with Kinney was in this room. Unfortunately, I did not take a lot of pictures. I look back 50 years, gee, why didn't I take a picture of that? Why didn't I take a picture of this? I do have some pictures of the operation. The machine over here on the right is a black and white Kinney I'm going to talk about. This was our color Kinney. I'll talk about that in some detail. And behind me, there's a machine that I don't have a picture of, but I found this in an RCA catalog. It's RCA's TFR1. A few embellishments over the earlier machine you saw in the previous photos of an RCA Kinescope recorder. This had automatic level and a few other things to make the operator's life a little bit easier, but it still used a camera down at this end. There's the 1200-foot magazine on top and the CRT down here and all the controls, the sweeps, the whole bit for the system there, the motor control. Oh, I didn't mention that because the camera, the film camera recording the video has to be lined up frame-wise with the television image. The motor was run, actually you stripped the vertical pulse from the incoming video and you drove the camera motor with that. So it was lined up. Once you got the phasing established, it pretty well stayed tracked and you didn't have any slippage. Okay, there's the room again. Let me move in. That is the color Kinney machine. You see sort of a side view on the left over here of the Teledyne color Kinney. A little bit different. It had a Kodak monitor with a very special cathode ray tube, again, a color monitor, and a camera here, which was unlike the other cameras. This was the Millikan camera. Instead of using claws or sprockets to pull the film down to get that very fast pull there during blanking, the camera used compressed air. There was a loop of film in the camera. There was a little jet. This thing tied into our house air system, supplying compressed air. And what you don't see here over the top of this thing was a blimp, because believe me, once this thing was up and running, it made a lot of noise. It was always kind of interesting to hear the startup of the Millikan there. You'd hear a pop, 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 and go up just like a motorcycle firing. And it was about that loud, I'll swear. So there was a sound deadening blimp that went over the top of this thing with doors you open to load the camera. I don't know why it's not in this picture. Probably this was just an ad picture I found, and they didn't show that. They wanted to show everything in its true glory. Not going to say too much more about the nits and grits of Kinney. I do want to refer you to an article here, an excellent article by Dick O'Brien, Richard O'Brien. I was very privileged to get to meet Dick in the last several years of his life. He died, I think, at 97, just a few years ago. He started working in television, believe it or not, in 1939. He was a grad student at Stanford. and he got called down to Los Angeles for a special project at W6XAO under the tutelage of Harry Lupke. That project was the first telecast. This was during his winter break there at Stanford. The project was the first telecast of the Tournament of Roses parade in Pasadena. So Dick was in television for a long, long time. He was a big man in engineering when he retired from CBS in New York. But I did have the pleasure of making his acquaintance. We had many interesting conversations, and he downloaded a lot of information to me. But he put together an article in 2004. Now, this is from the SMPTE Journal. You might want to write this down, January 2004. Ordinarily, the SMPTE journals are behind a paywall. But because, I guess, of the scope of this article, it's just such an intriguing, such an interesting article, and it involves Kinescope. It is available. Just, search. You could probably search Coronation of Queen Elizabeth, the same queen who's sitting there now. We know Queen Elizabeth. This was 1953. And Dick was given the project as a young engineer of being able to put on the air parts of some of the proceedings of the coronation the same day it happened. There were no satellites, there was no undersea fiber. We didn't even have undersea telephone cables. The telephony, telephone calls to Europe at that time, and for several years after 1953, were all achieved by high frequency shortwave radio. So how do you get video back? Well, Dick picked up a couple of GPL Kinescope machines, processors. They rented space in a building at Heathrow, much smaller airport then. Picked up the signal off the air, Kinescope thing, cut one version of the film there. CBS had rented a Strato Cruiser. That was about the biggest, fastest thing they had. There were no commercial long distance jet aircraft. And they had editing tables, I think 5 editing tables, flatbed editors installed where the seats had been taken out of the plane. And CBS editors cut another program as they flew back across the Atlantic once they'd gotten the last reel of film out of the processor. And the plane landed first in Newfoundland. The Canadians, of course, wanted their share of this. They got a copy of the film. And then they had another plane chartered, ready to fly the film down to Logan in Boston. CBS had video lines run to Logan and a Kinescope, not a Kinescope machine, but a telecine there, film camera, to pick up the film. And it went to the whole network all in the same day it happened. So just very remarkable for 1953. Again, look that article up. It is available outside of the normal paywall for the SMPTE journals. Okay, I was going to say that's it, but wait, there's still more. Okay, as I say, I seen on television. Back in 62, in the same SMPTE journal, not the same one with that article, but in 62, a couple of guys, Tarnowski and Evans, got to playing around looking at some numbers, looking at how can we improve the Kinescope process. And they came up with the fact that if you've got 27,000 volts accelerating the electrons in a cathode ray tube, making light out of these on the screen, you're getting about 10,000 quanta out of the electron gun at the size 460 microns there. You focus, you go onto the film, just like I showed, but you only deliver 30 quanta to the film. 10,000 down to 30, that's 0.3%. You're wasting a heck of a lot here. There's got to be a better way to do it. Well, a lot of brains prevailed. This is, I think, the understatement of the year, probably 1962. They said about this loss, the overall efficiency is very low. Yes. Well, fast forward a little bit, 1965. This is the first mention I could find of this new Kinescope technique, electron beam recording. SMPTE is going to have their annual tech conference, this time in Montreal. This is 1965. In November, October into November. This was a preview. Down here, this little blurb that appeared in Broadcast Engineering talks about EBR technology. I blew this up here just so you can read it. Again, I'll paraphrase it here. It's a very enormous capability in the system for capturing, storing information, but you've got several basic problems. You've got to run film in a vacuum. And I'm talking a very high vacuum, the kind you find in a cathode ray tube or a vacuum tube. And how do you do this? How do you get this moving film in and out of an airtight vacuum system? But they say if these problems can be overcome, EBR is expected to supplement, possibly eventually replace present day videotape. Well, leave it to the same people that make Scotch tape and all of these nice N95 masks that I know we're very familiar with. The 3M people there in St. Paul, their Mincom division, they produced this machine, started shipping them November 1968. And the machine was comparable in size to a video recorder, quad video recorder of the day. This is what we had in our Kenny operation. You see it there over here on the right. That's the 3M Kenny machine, EBR. Film magazine here. You loaded the film in a dark room. You brought it out here. This sealed into the system. There's a vacuum tight seal here. There's a fairly low vacuum there, about 10 to the -3 torr. It goes through progressively through some seals. The film is moving. This is the electron gun. The film is exposed here. You've got a vacuum there of about 10 to the -5, 10 to the -6. So it's just remarkable they could do this. They had 4 vacuum pumps in the machine, 2 mechanical roughing or backing pumps, 2 diffusion pumps, oil diffusion pumps, a lot of valves, a lot of interlocks, but the thing worked. Most of the operators, I've got to say, chose to use the conventional RCA TFR Kenny. They were a little bit afraid of this thing. It was very sophisticated. And one of the things, because the film is being dried quite a bit there, the vacuum is sucking the moisture out of the film. You could build up a charge on the film. You've got a 27,000 volt electrons hitting it. You could get zapped. So this machine was not used that much, but I did do a lot of study on it, knew it fairly well. Let me keep going here. The advantages, you've got no optical lenses, no optical glass in the system at all. It's beautiful in that respect. You don't have the granularity of the phosphor. You still got granularity in film, but not nearly as bad. It was a continuous, because of blanking, it was a continuous movement of the film, continuous projector. So you're not dealing with this high speed pull down, and you had extremely high resolution. This is a little blurb there in their advertising literature. Actually, it looks a little wavy here, but the 3M people are showing the difference. When you magnify, you see the scanning lines there, not much noise between them. Here's what you see when you shoot a conventional kinescope. So we had a lot more resolution, a lot less noise. This is a schematic they provided of the electron gun assembly, conventional electron gun more or less. It did have a replaceable cathode because these things did burn out. And I've replaced some of these. I'll show you what they look like. I believe you have electrostatic deflection. I believe it was vertically deflected. Electrostatically, you have a focus coil down here. You've got a deflection yoke for the horizontal deflection. You have the film over here, the electron beam is hitting. And here you have something you don't find on a CRT, a Faraday cage. This is kind of cute. What it was, it picked up some of the scattered electrons coming out of the electron gun, which had been video modulated. You fed this back, you amplified it. You could make a picture from it. So you could actually see what was being deposited on the film there electron-wise as you went by. It was just sort of a confidence thing. Again, here's they use the same sort of thing Kodak did, the coaxial film reels down on the right. And the film went through some seals here, very good seals, low vacuum, progressively higher vacuum till over here on the electron gun. Again, you're down around 10 to the -5, 10 to the -6 torr. So you had the same sort of conditions you find in a regular cathode ray tube. Film went back out. In our situation, it wasn't taken up here. It went through a light tight tube right over to the processor. Beautiful machine, made beautiful Kennies. We didn't exploit it nearly enough. Not to be outdone, everything was going color there in the late 60s, early 70s. 3M came up with a color version called the Chroma Beam. We did not have one of these. It employed the same sort of Peter Goldmark field sequential color, red, blue, green, blue. I forget what the sequence was. I've read about this thing. I never worked with one. And you gated the colors on, gated the fields on, recorded them sequentially, frame by frame on the machine. You had a special printer. You printed, you had the black and white film with these free separations, red, blue, green separations or records, and you printed these on color stock, one frame at a time overlaid by the other. Special printer. You had some really nice looking color. I have seen some of this film produced by this machine on the air. It's quite striking. It looks very, very good. The cost was a little bit pricey, about $100,000 in 1971 when it came out. That's edging up on $700,000 in today's money. I don't know how many 3M sold. So I'm not going to go through these claimed advantages. I don't think they're claims, they're real advantages. I think one of the best things going for the machine is the high resolution and the fact you're recording on black and white film, which is really archival. You don't have any color fading. The film, if you've got a regular, like a Technicolor thing, or you do color separations from a color master in conventional movie making, you have 3 colors you've separated out, and one film could shrink selectively in storage over a long term compared to the other 2 or vice versa. And it's very difficult to line these things up if there's some shrinkage. But because everything here is printed in groups of 3s on the same roll of film, you don't have that differential shrinkage problem when you're trying to print this out later as a color image. And you can take the film you make out of the thing. It's not like videotape. There were very few small portable videotape machines that could play color then in 1971. So you could take this 16 millimeter color Kinescope film produced on the EBR, play it anywhere you had a 16 millimeter projector. So I think I should be wrapping up, but wait, there's even more. This is the real mind boggler, at least for me and maybe for some of the others. In doing some research, I found that capturing and preserving images, television images on film, persist here in the 21st century. Or as I say, why in hell didn't they just videotape it? Well, maybe it's because you can't buy videotape anymore. So this is very prophetic. Howard Chin, he was the big man in engineering back from the get-go in the late 40s on into the 50s at CBS Television. This is from his textbook, Television Broadcasting, 1953. I'll let you read it. He is prophesying 1,000-line television and prophesying digital cinema because it costs just too damn much, he's projecting, to make things, movies that would have been made on film. He sees everything going electronic. And I don't know whether he foresaw digital cinema where you actually have a digital projector in movie houses and they're shipping around hard drives or shipping around data files through the internet to feed these projectors, however they do it. I know they were shipping around hard drives for a while. I've been out of that business for some time. But anyway, the need has arisen for television recording of these high resolution, high definition images. And RA, the people who make the very nice, very, very excellent and very expensive movie cameras, came up with a Kinescope recorder, a state-of-the-art recorder, about 1999. They improved on it, had the second release in 2009. So this is a fairly mature device. It uses lasers. Film is not in vacuum. Here you see the supply reel here, and the cassette is open. There's a take up. The recording mechanism is there where the laser beams hit the film. You see the film going through. I'll show you the light path there from the lasers. There, the lasers firing. Beautiful picture they sent me. And here you see the red, blue, green lasers, and the light is being converged here at one point, brought up. It's a 90-degree mirror, comes through. It's another 90, goes right onto the film as the film is going through. Beautiful images. I thought that was it. In doing research, so I found somebody else is making a television film recorder, a company called Cellco out in California. They have several models. Looks a little different than the Ari. You see the take-up supply reels are on top, mounted vertically, but basically does the same thing, makes very high resolution images, can work in HD, UHD, but it does not use lasers. They use a CRT. They claim the resolution is as good or better than you get with a laser. So here we're back to CRT, electron beam. It just never ends. So I'm going to end right now. I've gone way too long. I'd like to say Kinescope recording is still not a lost art. It's very much alive here in the 21st century. It just looks a little different now. My time's up. Thank you for yours.
James, that was fascinating. I really, really enjoyed that, and I learned a ton.
Well, I went a little fast. If anybody has questions, if I can answer them, I certainly will.
I've got a couple.
Okay.
First off, any idea what the oldest extant program that is still around on Kinescope might happen to be?
I really don't. Is James Snyder in the viewing audience working with the Library of Congress? Because they have a lot of archival material. I do know that a lot of these Kineys, they weren't only used for time delay, they were a proof that a commercial ran, a sponsor's commercial ran at a given time, legal proof. They were also given to sponsors, people who spent these big bucks sponsoring these shows. They gave copies to sponsors. And it's interesting, I have anecdotal information in cities that did not have television early on. These were shown sort of as a novelty in motion picture theaters. I'm thinking of Alaska. It's quite a while before Alaska got its first television station. So there are a lot of these Kineys that floated around. How many exist today? I don't know. And I do not know what the oldest television show recorded on Kinescope is. I do recall seeing on PBS many years ago some newsreel footage. Apparently Paramount, one of the newsreel companies, had gone into Philo Farnsworth's TV station, experimental station in Philadelphia in the 1930s. And this was sort of an accidental Kinney they made. They were shooting programming off a monitor. That might be the earliest Kinney of an electronic television image. I don't know. It was not intended to be a Kinescope recording, but nonetheless, a camera is shooting the monitor. You do see the shutter bar going through it because of the different frame rates. But I don't know. That exists somewhere in newsreel archival footage, but I really can't answer the question. So if James is there, maybe he could chime in and talk about what is in the repository out there in Culpeper, Virginia.
Okay, and just as a local question, since I'm originally from Dodge City, how did the voice handle video feeds to the PAL end countries like Argentina, Paraguay, and Uruguay, or did they depend upon Kineys for those nations?
First of all, please do not say voice, because are you able to hear me?
Yeah.
I'm looking up there. My little frame is not illuminated. It doesn't have the border around it. But don't say voice, because most all of the time I was there, it was U.S. Information Agency's television and film service.
Okay, so my
there were several
apologies.
siblings. The radio people were totally across the mall, totally divorced from us, management, everything else. Once we got a budget under Reagan, we set up a first of our global satellite distribution systems. I was out hoofing it around all over Europe in the fall of 1984, getting ready for that. When I left, we had 9 full-time satellite distribution systems, which obviated the need for Kinescope or anything electronically converted CCAM PAL tapes. But I imagine the conversion was done. Now, I got involved in this in converting NTSC to PAL for the Far East. I was involved in building a turnaround and uplink there at Delano at one of the VOA shortwave stations to take 525 60 video from Washington, turn it around, make 625 50, and send it out to Pacific Rim, because everybody out there other than Japan is a 625, or was before digital, 625 country. So I imagine the same thing was done in the satellite distribution into the South American nations you mentioned. Now, again, we did not have our own TV stations. We had to make arrangements, broker arrangements with somebody to take our programming. So you may or may not have seen USIA programming or later WorldNet programming in these countries. Now, I will say, just to complete the circle, about the last 2 years I was there, the WorldNet name disappeared. It became this horrible, for me, I don't like to say it, it's a horrible oxymoron, voice television, Voice of America Television. Think about that, voice television. But yeah, but most of the time I was there over 30 years, it was either USI Television or WorldNet. But again, to answer your question, I'm sure it was handled there at the satellite turnaround, because of course you can't satellite all around the world in one hop. Other questions?
I remember the Queen's coronation, and as I recall, RCA had set up enormous antennas at Camden or somewhere on the East Coast, hoping against hope that they might pick up direct broadcasts from BBC. They didn't, because it was about 1,000 miles too far, but they were just hoping for some magic skip so they could show it directly.
Now, I mean, you go back, you read the papers, I'm digressing, but yeah, the low band VHF signals from Alexandra Palace did make it across the pond in the late 30s. They were seen, I think, in RCA's lab there out on Long Island. There's no recording. I know there's an article in Radio News, I believe I saw this back in the 30s. We had some extreme skip activity affecting low band V. And they actually bought some receivers, some British standard TV receivers, had them shipped back. Of course, it was by boat. And by the time the receivers got to RCA, the skip had gone away, not to return again for a long time. But NBC did carry the coronation, similar to what CBS did. Dick O'Brien mentions that in his article, but CBS was first to get it on the air, and the network that we had in place they had in place in 1953. Not every city, not every town was connected. The first television station, and Chuck maybe knows something about this. Were you in Texarkana, that area in East Texas, 1953?
No, I grew up in New England. So.
That's what I thought. Yeah, you told me that. But the first television station in my part of the world, I grew up in Southwest Arkansas, was in Texarkana. And they took feeds from all four networks, including Dumont. They had affiliations with all four networks. They had a very limited broadcast day, something like 3 in the afternoon with the test pattern. They'd start programming around 5, normally off at 8:30. I think 2 or 3 nights a week they carried a movie. It would take them to 10 or 10:30. It was all local program and film, because just like the railroads, just like the highway systems, the major cities were connected first, the major population areas. Then they built spurs down to these smaller markets. So I think it was probably 3 to 4 years before Texarkana actually had a physical contact of coax microwave coming in with signals from New York to feed these network programs. And I remember very vividly seeing Christmas shows in January, some late January, because they had to bicycle these Kinescope recordings around. There was no FedEx, there was no ups overnight. It was either parcel post or railway express. That's how you, or maybe by bus. That's how you move these shipments around, including the Kinescope film.
I have a question, a comment first. The TFR-1 U of M Television Center had one. They were still using it up till 1970 or so. Occasionally people would want Kinescopes. The question I have is, was it CBS or somebody else that had the same sort of thing where half the film was the image and the other half was something else that was recorded with an electron beam recorder?
I don't recall ever reading anything about that in broadcasting. I will say, I was going to say this, I meant to talk about this. I talked with a Kine operator at one of the SMPTE conferences out in Hollywood, a decade or so ago. And there was one fellow who had worked in Kinescope, I believe for NBC there. And he was telling me that they made 2 Kines. Of course, you would do this just to cover yourself in case something happened to one, so you had a show ready to go. They would make 2 copies, but they would do one in 35 and one in 16 because the quality of the 35 was that much better. That's what they would run on air, and the 16 was a backup. So you can imagine 35 being much, much more expensive to purchase the raw stock and process it than 16. So just an incredibly expensive, incredible amount of overhead to keep these Kine operations going. But again, they had nothing else. There was no videotape.
Well, while you were talking, I just Googled it, and CBS did have something called electronic video recording.
Right.
And it was half the film was a black and white, and then there was a separate chroma track on the other side of the film.
Okay, the EVR, V as in Victor, yes, that was a consumer device. That was not a broadcast device.
Okay.
That was another one of Peter Goldmark's, follies. Goldmark was there. He started the television operation started the whole television program, engineering wise, at CBS back in the 30s. And he field sequential color, a number of things he did. And I know it's in Bill Paley's book. They quote Paley is saying, "I was really relieved when Goldmark reached mandatory retirement age, because the only thing, he was a brilliant man, but the only thing he did that made us any money was to invent the microgroove 33 1/3 record in 1948. Everything else was a lost leader, including this EVR. It was nice in concept, but about the time they had this thing ready to roll out, the Japanese had come out with VHS beta, and they had one big advantage you did not have with the EVR machine. You could record at home. You could erase, record again. The other was on film. You played it. You had no recording capability. So that went down the tubes really quick once the machines, a 1/2-inch video machine, started coming in from Japan. So yeah, I do recall that, but the reason it didn't register immediately, it was not a broadcast device. It was strictly for home, schools, things of this nature, industrial.
Yeah, I can tell you a lot about EVR, and because I worked at Motorola on the player side of it, and yes, the EVR died due to a videotape competition, but it also died because of William Paley's hemming and hawing. EVR could have been on the market at least 5 years earlier, but Paley was constantly changing his mind about whether entertainment product could be issued on EVR films for the home. He thought it would ruin the TV business. And as we all know, pre-recorded VCR tapes actually enhanced the TV business, but he couldn't see it. And as a result, he kept stopping and starting the project. And it finally got to the point where there was no market for it except training films, industrial films, and you could not amortize the cost of the cartridges over use of a few hundred copies rather than tens of thousands.
Right. No, it's a shame it didn't go anywhere. It was a good technology for what it was for a point in time. But again, it had a lot going against it. And you mentioned another one there. Bill Paley was not really sold on it.
Yeah.
Right. James.
A lot of things that Goldmark did that Bill Paley was not sold on. And for good reason, Paley had his fingers burned on a lot of things that Goldmark tried to do.
But James, why was video to film technology pursued long after videotape had been perfected?
Well, I can tell you in our case, they referred to this Kinescope room as our transmitter room because a lot of countries we could only make 525 60 recordings, quad video recordings. We could do color, we could do black and white. And not everybody in the world, as a matter of fact, the vast majority of the world is 625 50. So they could not play the tapes no matter how good the tapes were. So this was the only way we had of interchanging without some sort of standards conversion, because virtually every television station could run a 16 millimeter film and put it on the air.
Was most of the BBC stuff that we saw in the late 60s and early 70s Kinescope to convert it from UK format to US format?
I didn't watch a lot of television from the BBC, so I can't really speak to that. I would imagine, I know a little later on, what was the series Dallas, it went the other way. And because of the electronic conversion they were using, there was a tremendous amount of judder. I mean, this thing was shot on film. You had this 3/2 cadence. When they scanned it off the television, you put it on tape, you converted it to 625, distributed it in the UK. What I heard, it was really, really bad in that respect. It's possible. It's possible that the Brits were sending over, the BBC were sending over programming on film. But I do know that they also, Marconi, I could go and write a book on that, but I know the BBC engineering labs, they did work out on electronic standard converter fairly early on. And then later Marconi came out with the really first Cadillac, if you will, in electronic standards conversion. I know I was sent down to Florida, to Orlando. There was a small video production house that bought the first one in North America, and we wanted to have a look at it. So I went down with the producer to see what this thing would do. It was 2 racks. It was all TTL. And I remember this thing had copper bus bars, bigger than my thumb in the back. And those bus bars ran warm to the touch, delivering this 5 volts to all of this TTL silicon in the thing. But it would go from any standard to any standard, and it looked pretty darn good. But that's the first time I saw electronic standard conversion. It got a lot better. It got a lot cheaper as time went on. That was, by the way, what's called the Marconi dice for digital intercontinental conversion equipment.
There's a guy named Peter Marshall in the UK who worked for Marconi, and he has the original machine. And the second one of those is in the National Media Museum in Bradford, England, which is outside of Leeds. And oddly enough, the museum had the first one, and he had the second one. And the new curator of the museum liked the color of the one he had, so they swapped. So he got the first one. He's an interesting guy. He's just as crazy as all of us.
Yeah. But, like anything else, that was a first generation electronic converter, mass, if you can see mass produced, it was not a tremendously large market. Very expensive, very bulky, very energy inefficient. And everything after that was better, cheaper, smaller. So, yeah, but that was a groundbreaking moment there when Marconi introduced that dice back in the 70s.
James, you missed something that you didn't put in your talk.
What is that?
You talked about the laser recorders.
Yes.
There's another reason why they were there. In the early 90s, things like the discrete flame came out, so you could do visual effects on a computer.
Okay.
So you shoot a film, you convert it to digital, you do the processing of effects and things like that. And I'll even go to the movie Titanic. But the deliverable to the theater had to be back on film. So all the effects of what you've done at the high resolution had to be converted back to a film to give back to the studio to edit into the master print, which they make copies of. And I remember one time getting a phone call from some people, you might know Gary Demos is one of them, where he was saying, I thought I'd give you a call right now. We're waiting the laser printer to finish putting out that film about a guy ages backwards. I can't think of the title of it right now. And he says it's going to be another 25 minutes or so before this reel finishes.
Mm-hmm.
And at that time, we got an interesting discussion. And then one of the cute tricks you can find out that most films, they process it up to the day they have to ship it to the theater because it opens tomorrow night. And you'll find there's a color shift in the 20-minute time of the film reels because it's a 800-foot reel or something takes a day to write out the laser printer. And the film at the inner part of the reels is about a day old. The film at the outer part just got lased. And if you let it sit and age, there's a color shift. But they didn't have time to wait for the color shift because it had to open on Christmas Day in 3 days. So if you know to watch every 20 minutes, you'll see minute color changes, and then it switches, and then the minute color change, then it switches. If you watch films right before we started all electronic distribution of cinema.
Well, I imagine too, I think RA alone, the RA laser, I think they've sold something like close to 300 of these globally. I don't know how many of the cell codes they're selling. They're both products. I guess if you got a big enough bankroll, you can go out and buy your own. But I would imagine too, there's a certain amount of demand for films. Not every theater in the world conceivably is converted to digital cinema. Some of them, that would be the only sort of product they could take was a 35 millimeter film. And of course, that's where this technology here in the 21st century shines, making very high resolution color 35 millimeter prints from electronic
The other thing
files.
is We don't have them on right now, but it might be if you're going to register copyright, you have to supply film as opposed to a hard disk.
That's a good point. I wish James Snyder were here to talk about that.
Yeah.
By the way,
James
that's
is going
why
to
so
be
much of this
James is
stuff
going to be
exists.
speaking at an upcoming meeting, hopefully, so we can ask him those questions.
Okay.
Yeah, save the man.
There's a pretty interesting film that came out in, I think, 1963 called The TAMI Show, TAMI, which stands for Teenage American Music Industry or something like that. It's a music video, and it was shot using RCA TK60 cameras running at 819 lines, the French standard, and it was recorded as a kinescope and then released by American International Movies for drive-in movie kind of things, you know, so it could be shown in movie theaters. And it looks absolutely amazing. It's almost high definition video. And apparently from what I understand, the Kinescope recorder was made by RCA, but I don't know anything about it past that. Does anybody?
Well, it could have been a improvement, another tone higher, another tweak or something on that TFR1. TFR, by the way, television film recorder, that simple. RCA made the names very indicative of what the product was. Not TC for television camera, but TK for television camera. I don't know.
This thing looks absolutely amazing. You can buy the Blu-ray version of it, in fact, and it's pretty darn amazing. I mean, it's really high definition black and white video shot with black and white RCA cameras, and they were doing it to save money. I don't know if it saved them any money or not, but it was an interesting idea to shoot a feature film in video.
Well, just remember one thing, when you said 890 lines or something like that.
819.
Let's say 900 lines. When Lucas shot the first 3 electronic versions of his Star Wars, he used a 1920 by 1080 camera, but to get the aspect ratio he wanted, he's about 880 lines vertical resolution. And that's what they delivered to the theaters.
That's a pretty acceptable picture. I mean, we watch 720p all the time and I think it looks great. So,
you know, it's something you're going to, if you do pull that article by Dick O'Brien about the coronation, he talks about the 405 line video, which what the Brits were transmitting at that time. And if you've ever seen 405 line television, it is a very, very visible line structure there. The lines are pretty far apart. So they use something called spot wobbling. They put another yoke over the CRT and ran a fairly high frequency, I think something like 10, 12, 13 megahertz, which wobble the spot as it was scanning to try to fill in the blanks between the lines. And I did a fairly acceptable job. I've not seen that, but that's what Dick said in his article.
James,
you
probably on the 1950s Kinescopes, the ones the first ones we're familiar with, were they double system for audio and video?
It depends on who did it. The network level, everything is going to be double system just for facilitating sound. I didn't mention this. I did mention the P11 Phosphor. The film for the Kinescope, Eastman, DuPont, others made special Kinescope recording film. And the film was designed to be, or engineered to be, sensitive basically to light in that part of the spectrum, the violet, the blue that the P11 Phosphor threw out, and relatively insensitive to other colors, which made it fairly easy. We have bright yellow safe lights here in this this changing room for these magazines. So you didn't really worry about exposing, fogging the film like you would with a panchromatic emulsion. But what I was going to say, if you used a double system, you could either use a very fine-grained, slower film, because you can get a lot of light through a light valve, a galvanometer light valve, to make your soundtrack. You can get a better quality soundtrack, less noise, or you could use magnetic tape for your soundtrack, interlocked with the video there, so everything stays in sync. But again, you look at motion picture sound. The sound head is what is it? 9 frames, 12 frames away
No, it's
from.
more than that. It's 20 something.
It's a long way away. And you
21
cut the
frames
film at one
exactly.
point. If you have single system, you're invariably not going to get clean edits all the way through your editing project. But if sound is on a separate film, under a double system, you can always do clean edits. So it depends on the skill of the editor, but it's much easier to do it if you've got double system.
As a side note, 819 was the French standard in the early days of television.
There was also a system compact video did, James. You probably remember that.
Oh,
It
yeah.
was hot around 1978, 79, and that was 655, 24 phase alternating line, alternating field composite video. And they edited it on AVR1s with a special wideband module in them. And that was shown at SMPTE meeting.
I went to the compact and I saw them with a demonstration of that at one time.
The comment on 405 line structure explains something that I wondered about, because I saw 405 lines over in England in the late 60s. And I thought to myself, this looks nearly as good as 525. I don't see any line structure. And that may be the reason that they kind of wobbled the lines, so it wasn't as prevalent as one would expect.
Well, don't claim to be an expert on British consumer TVs, but some of the TVs might have had this extra deflection there to spot wobble the scan. I don't know, but I know O'Brien mentions this about the mod they did to these GPL Kines. They had to adapt them 405/50, and also they put in spot wobbling to make the line structure less visible. But I have seen 405, native 405, and converted 625 to 405, and the line structure is quite visible.
James, can you talk more about that pipe that ran from the back of the camera into the film processing machine?
Yeah, it was just a tube, a light tight tube. The film flowed through it right out of after it was exposed. So you didn't fog the film there in the room under room lighting, and went right into the processor. And a minute and a half, 2 minutes later, the film was spooling off there, all dry. Once it was all finished, ready to take down and project, or in our case, put it in a package and send it somewhere.
Wow.
I'm curious about the similarity between the old Kinescope, and that's interesting, that spectral sensitivity tidbit. But fast forwarding, you mentioned that these newer machines also record on film. Is that an actual silver halide film? Is it that much of a similarity with Kinescopes? Or, I mean, do you have to
the film. I mean, film is film. It's a silver halide halide process.
All right,
light sensitive.
So does it have to be developed then subsequently? How do they?
Oh yeah, that's what I mentioned. I went online. I found some labs that still do motion picture footage, and I'm sure there still a number of them there in the Hollywood area. Certainly not like it was in the heyday, but yeah, there's still places that process film. Kodak, I think, is the only company, at least here in North America, that makes movie film, because there are some purists out there, directors, who do not want to shoot digital cinema. They want to shoot on film. They like the quote unquote film look, and are not going to be dissuaded by what you can do electronically to try to simulate that with digital cinemas.
Yeah, it's kind of infinite resolution because of the silver halide crystallinity in it. But I'm curious, do they both vendors use the same source for their film that they use, or is there a difference there?
I can't speak to that. I would imagine
okay.
you could use anybody's film, but again, as far as I know, at least in this country, the only manufacturer of film, of movie stock, is Kodak. They're sort of hanging on. Kodak is nowhere near the company it used to be. It really shrank. They did not get into electronic imaging except in a very small way. Too little, too late. I know they came out with the camera to compete with Polaroid, the instant camera. They got sued. They lost a bundle there for infringing on Polaroid patents. So yeah, Kodak. I love Kodak. The father there of all photography in Eastman, George Eastman. But again, the company is just a shadow of what it used to be, unfortunately.
Yeah. Okay. No, thank you.
Okay. Sorry, I couldn't be more definitive, but I can give you some contact information at RE, and I know the PR person for Selco.
Well, I think silver halide, like rock and roll, is not going to die.
Yeah.
Go on forever.
Hey, James?
Yes.
With regard to the RCA TFR1 and also the Teledyne CFR-2 there, approximately what years were they manufactured, and about what was their approximate cost back then?
I couldn't really give you a cost on either one. Again, these were all in place when I went to work for the agency in 1975. I think they'd been operational. We just moved into I was not part of the move, but the year before I started, 74, they had just moved into this new facility built out for television, 6th and D Northwest downtown Washington. And I'm sort of assuming, since these things were not pristine new devices, none of them, the EBR, the TFR 100, or the Teledyne 2 there, they had been used at the other plant, which, by the way, was the old post office, which of late has become the Trump Hotel. So that's where the television service was operating before the move to 6 and D, and these things were moved. So I really have no idea what they paid for them or when they came out. I would assume the TFR probably came out late 50s, maybe. Again, I think a lot of people were sort of hedging on developing new products for film because of what videotape had done. I know Ampex hired a marketing person. I'm sure you've all heard the story before they showed this VR 1000, and they expected maybe to sell a dozen machines globally. The only purpose they could think of for a machine like this would be for time delay. The networks are going to buy a couple, and that's going to be it. And I talked with one of the people who invented the machine, one of the team. He said in Chicago, said we ran out of order forms. We were taking orders on cocktail napkins. Before the weekend was over, these machines were selling for around 75,000 in 1956. Said before the weekend was over, we had taken orders for, I think, something like 80 machines. That was more money than Ampex had made with all of their audio sales the year before. So yeah, people were a little nervous about developing anything film-wise because videotape did take off a lot faster than I think anybody had predicted. And I thought it was a rather bold move on the part of 3M to spend all of the R&D money developing this electron beam recorder. Now, I will say something else. In doing a little research for this presentation, I saw they also made a version for data storage, computer data storage, because it was a very high resolution storage media. It could record a lot of data. So television was not the only application for the EBR. So I'm sure they made their R&D back at least, even though they didn't sell a tremendous number of these because by the time it came on the market there in the late 60s, virtually everybody had videotape. Again, we were starting to get into the era even of electronic journalism, doing away with 16 millimeter sound cameras to go out and capture news and having to develop the film there. That didn't take too long once that started in the 70s to completely wipe out that part of film in a television operation. So yeah, I can imagine RCA, the others would have been a little bit nervous about putting too much R&D into another film device.
James, I wanted to ask a question about the color Kinescope machine that you had in your photos there. It recorded on regular color imaging film, or was there a special film for that?
No, it was an Ectacolor film. No, I think it actually an Ektachrome film because we did not make multiple copies typically. It was a one-off thing. I was going to talk about this, but I didn't want to take a lot of time. That was one of the advantages of Kinney. You could take negative film, you could flip the polarity, add an extra stage of inversion of their amplifier in your electronics, and you could come up with a positive. You recorded a negative image on negative film. When you went to play it back, you had a positive without doing a reversal, without printing this on another piece of film. So you could do that. You could change polarity. You could change the direction of sweeps. I'm not even going to go into that. That is something to do with the emulsion side toward the screen. But we did not make negative masters. It was a one-off thing. The film we used for both black and white and color was reversal film. So it was ready to project. You didn't need to strike a print from it. I don't know whether I'm answering your question or not, but again, it was just conventional Kodachrome, not Kodachrome, Ektachrome film. I think probably designed somewhat for Kinney, maybe a little stronger base, but this machine did not have that pull down problem I was telling it, very fast pull down, acceleration, deceleration of the film, because it used compressed air to pull the loop of film down. So I don't know what was really special about the film. If anything, it might have been the film that used to go out and shoot news. I really don't know. I didn't operate the machines. I didn't buy the film. I just came in and fixed them when they broke. But it was just basically the camera shooting this Conrack color monitor, high resolution monitor with a very good CRT in it. Now, we did, God bless the guy again, I mentioned Mr. Kinney, the Naval Photo Lab, I think later became Naval Imaging Center, had a Kinney operation. They had the later model Teledyne, the 3, and it did not use the Conrack monitor with the CRT. It used 3 small CRTs. These were like 5-inch CRTs with red, blue, and green phosphor. And just like you saw there in the laser beam picture I had of the ARRI laser machine, they were converged back as they hit the film plane. So this machine probably had better resolution, looked better than the other machine. But I know Frank had this machine, his branch chief I was talking about, Mr. Kinney, acquired this machine from the naval photo people, had it brought across town. And as I was designing the electronic conversion facility, there were a couple of technicians trying to restore this thing back to operational capability. We never used it though.
Interesting. I was reminded of a presentation at a SEMTI conference. I think it was here in Detroit at the Second Color Conference, where they had a thing, I think it was Technicolor. They were making color kinescopes and distributing the commercials on film because they could get them out faster to the stations that way than trying to make all the dubs on 2-inch tape and get them out.
Oh yeah, that's something to be said there. Even though Ampex, believe it or not, did make a high-speed, what they call it used a mirror image master. You could duplicate tape at faster than real time. I've seen a couple of these machines. They're big, they're very expensive. Ampex didn't make many of them, but yeah, you could do high-speed duping, but certainly film would be a faster way. You could strike a print much faster than in real time to pull up, strike a print that way for release, especially short link commercial type.
In the late 60s, people didn't have the banks of quad machines that you could make 10 dubs at a time or whatever, and the high speed hadn't come out yet.
Oh yeah, but you know, again, I did see those Ampex machines, like a big flatbed there. The tape was a special high coercivity tape made by DuPont, chromium dioxide, I believe, and it was the strangest thing. They had an AVR1 machine with the head turning backwards, the control track, the audio head reversed, and the tape moved through the machine in the wrong direction. And of course, this is what they call the mirror image master. They took this, squeezed it in contact with regular videotape, ran it through a low intensity magnetic field, and you had print through. You had intentional print through onto this, the conventional iron oxide emulsion on the tape or coating.
Yeah, there was
Wayne, you were
one
going
in
to say
Ann
something?
Arbor at the NET facility, and it became something else, and it caught fire and burnt down. That was the end of it.
Yeah, well, these are the ones I saw were at EUE Screen Gyms in Manhattan. That was back in the 70s.
There was one
CBS was still sending out Kinney promos as late as 77, 78. And we used to run those things, and they were just embarrassing because they looked like hell. And the supers were all orange, and the smearing was all over the place.
Well, let's
So
say
they
our
were really
Kinney,
bad quality.
our Kinney operation persisted way into the 1980s, almost to 1990, because this one particular branch chief, he did not want to let go of the Kinney. I think he understood Kinescope, understood film more than he understood anything else. I'll say this anecdotally, and this was a nice guy, Frank, but I got one of the early CAD systems. This was before AutoCAD came into its own. This was a proprietary program, and it came with a big Tektronix cathode ray high resolution monitor. I think the monitor for this thing was probably $25,000. It was an expensive system, and this monitor, beautiful high resolution. I'd never seen anything that nice. And it had its own color bars for setting the monitor up, just evaluating. And I had this thing, and I was playing with it, had it in color bar presentation. Frank walked in my office and saw this thing. First words out of his mouth were, "My God, that would make a great Kinney machine."
Now, was a Kinney machine something that you would see at most TV stations are only at the networks or at very few stations?
Basically only network level or the major market stations, because it was just such an expensive thing to maintain. I mean, you've all this cost of film and processing. Now there is a Kinescope, which is a fairly good looking Kinescope. It's a dedication of Channel 9's broadcast house, station now WUSA, then WTOP TV. And this was done on Kinescope. They moved into broadcast house before videotape. I don't know that they had a Kinescope machine there in broadcast house. I almost think this may have been done by feeding the video that night, this dedicatory program to maybe New York or something, and it was Kenny there. I don't know.
Yeah, I know we did not have a Kinescope ever. We have some newscasts that CBS cameramen shot off of a monitor from those Don Richards shows from the mid 50s, but there was never a Kinney at broadcast house.
But I went out to Chicago in, I think, about 1972 to interview for a job at the PBS operation here, WTTW, WXXW, and they did have a Kinescope operation running then. I remember seeing that. That was the first time I'd seen a Kinescope machine.
James, were most of the Kinescope machines of the 50s 35 or 16 millimeter? And how about in your facility? What were they?
All 16, just because of the cost and simplicity in handling the film. Again, I say the networks had 35. I was told, I don't know this for a fact, I never saw this, but I was told at least NBC, they made 2 recordings every day for the 3-hour delay. The 35 millimeter went to air. The 16 was backup in case something happened to the 35.
Local stations would not have 35.
No. Local stations, you know, very rarely would have a Kinescope machine at all, just because of the operating cost.
Now, did the Kinney machines use safety film, or was it I want to say nitrite-based film?
All 16 millimeter film is safety film. You will not find 16 millimeter nitrate film. So yeah, that's one of the advantages of 16 millimeter Kinney. You're never going to have a film that requires a specially trained operator to use. And I worked as a motion picture projectionist in high school. I was shown what 35 millimeter nitrate film could do if you caught it on fire. And I was told, as a 15, 16-year-old kid, if you ever remotely think what you take out of the film can here is being shipped to the theater is nitrate, you call me immediately. You don't touch it. So no, there was not a lot of nitrate film used for Kinney purposes. I would not think.
James, the 35 millimeter stuff on the West Coast for time delay that was being done double system audio video, was that eventually printed with the soundtrack on the edge of the film?
Oh yes.
Okay.
I mean, if it went anywhere other than for network delay, now they were doing Kinney in New York, they were doing Kinney on the coast for different purposes. As I say, it took a while before AT&T connected all of these affiliated stations. So that was the only way to get network programming to these stations, was to make Kinney's in New York and ship it out. And of course, the stations by and large did not have double system. They couldn't handle that. It had to be an optical track printed on the film in sync with the video.
Well, the first video cable coast to coast was what, 51?
I believe you're right there, yes. But as I say, you know, it's like the highways, like the railroads. The big towns, the big population center areas were connected first. Then they worried about tying in the spurs, the smaller markets.
Okay, thank you.
You know, with all of this talk, we've been talking about Kinney recordings and stuff like that. It reminds me of Dumont's Electronicam system. I have serial number 1 of 3 cameras that were built by Dumont there, and it would sister a black and white camera there with an Airflex camera through a special lens that they developed. And I'm thinking how they made film recordings that way.
Oh yeah, that was Dumont's baby, and of course you didn't have the Kinney look. It was again the film camera ran 24 frames a second. There's no mechanical conversion 30 to 24. It was a nice thing. Again, you basically had a beam splitter to send part of the light to the television camera tube and part of the light to the motion picture camera in the same box, as you know. So yeah, that's why the honeymooners some of the other very, very rare footage from Dumont still survives and looks so good when it's put back on the air, seen on television.
Right. Like the good Honeymooners episodes were the ones done on the electronic cam, and the lost episodes were the Kinescopes, and they look it. I mean, the distortion is tremendous. The curvature of the screens.
I believe the last 39 episodes of the Honeymooners were filmed with an electronic cam there. And
Right.
of course, you can tell a big difference there. But I have all the documentation from Dumont, all of the interoffice memos and everything. I have the only existing memos that they did with, they also have pictures and what they were doing. One of these days, I'd like to get that, copied and published there a little bit. But I've got every interoffice memo that Dumont made regarding an electronic cam. So that's my claim to fame in that regard. But anyway.
Dumont had a kids show called Captain Video that was done on electronic cam prior to Jackie Gleason's Honeymooners.
That's correct. Yeah.
That's
we have the Captain Video version at the Texas Broadcast Museum. One in the sales literature, they suggest putting color reversal film in the camera, which I think is an interesting idea. And they say that way you can make black and white prints on it right now. And when color becomes a de facto thing, then you can make color versions of your 1951 TV show or whatever, 1955. Pretty ingenious. I don't think anybody did it because the color reversal film was really expensive, but you could do it. So that was kind of an interesting idea.
Yeah, I'd never heard of
I know
this.
they used these till 1957 or so when when videotape took over, and all of a sudden that made more sense. So
Yeah, Chuck, you have serial number 2, I think.
Yeah,
I've got serial number 1.
that's correct. Yeah.
And I've got all. One of these days, I'll make copies or let you see the documentation for these cameras.
I'd like to see them. I'd be really interested to know how many they actually made, because I've never been able to find real good documentation on that. But
As far as I know, they made 3 of what we have, the 16 millimeter version.
Really?
There was only 3, and somebody's keeping what? Does Chuck still have that?
No, ours is Chuck. It came from Chuck Ferris.
Right.
And there's one in a museum down in South Carolina or North Carolina, something, but it's not complete. I've seen pictures of it. I haven't seen it in person, but I know the side that has the camera cable connector is smooth. There's no connector on it, and there's no hinge for the viewfinder. So I don't think it's quite complete.
It's in the collection at the South Carolina State Museum.
That's it.
In Columbia, and it's from the collection of Thomas T. Goldsmith that he donated to them when he was on the faculty at Furman University.
Okay. That makes sense with what I've heard or what I've been told.
From what I understand, the 3 cameras that, like you and I have, they were some professor up in Princeton University that Dumont donated these cameras to the university there. And then from there, when they weren't going to use them, what's his name up in Chicago that had that museum up there? He's the one that sold them. And anyway, he gave me all of the documentation he had. And as far as I know, that's the only existing stuff there. You need to see what I've got there.
We've got some sales literature, but we don't have any document, nothing technical about it at all.
Yeah, just you wait.
Okay.
I got it.
I got a copying machine.
Yeah, it's interesting, but I've got all the interoffice memos there, and some were signed by Dumont himself. And that should be an interesting read.
Bruce Dumont, that's his nephew, who's got the museum in Chicago. But there was another guy in Chicago that had a bunch of Dumont stuff too. He sold it all a long time ago, though. Anyway, I'm starving to death, folks.
I think we sort of beat this to death, and I see the number of attendees is falling off. So I hope I didn't put too many people to sleep.
No, it's been fascinating, James. I really appreciate you doing this.
I got a question for you. It's a little bit off topic, but I can't imagine how they could pass the film in the EBR machine into a vacuum and maintain a seal there. I saw we had John Yurkon on before, but he might know how to do you know how they did that?
Well, I'll tell you the way the thing worked. Again, the film was loaded into this special. Let me go back and find that picture if I can, if I still got it.
You said it traveled through different regions.
Yeah, you
too,
had
so there
this
must have
coaxial container. The film reels were on the same axis, and you loaded this in the loading room, the changing room there, dark conditions, safe light conditions. You brought it out. There was I'm not going to say rubber, some sort of a vinyl material. You seal this thing in, you tightened it down. There were four lock nuts, I believe. You tighten this down real good. And it took several minutes to make the vacuum, but you had the low vacuum there, the mechanical pump, the roughing or the 4-pump. It pumped down to about 10 to the -3 torr. And then the film, there were a couple of little slots. It went through various slots. I don't know what the material was. Apparently it was chosen, so it was a fairly good air seal, and also something that would not scratch the emulsion on the film, which is quite a delicate thing. But it went through there, and then the vacuum progressively got increased. The air pressure got lower and lower till you're right around the electron gun there where the film was exposed. And that was down to about 10 to the -5, 10 to the -6 torr, according to the book. And you had a vacuum gauge on the machine, a thermocouple type vacuum gauge, and of course a very well, I'm trying to think of the term, but mechanical gauge for reading the vacuum there in this chamber where the film magazine was, the film reels were. So yeah, you could see the vacuum go down. You'd have lights that come on. You had interlocks. And I mentioned the replaceable cathode in the thing. And somebody did something stupid, like try to take the film off while the electron gun was still on, still accelerating electrons. You had a lockout system. Supposedly you couldn't do this. You could do it, but there was a shutter that would come up and seal off the vacuum so you didn't burn your cathode out. It would burn out in just a few seconds, otherwise being out of the vacuum. That was defeated once in a while, but I did replace some of these cathodes. I have a picture of this. I don't know why it wasn't in that deck. I thought I put it in the slide deck, but I got a picture of my wife holding two of these things, one in front, one in back. They're 3 little hex head screws you take out. You can actually put a new cathode in. This was the mouth she's holding, but these fitted into that electron gun assembly. But yeah, you had these diffusion pumps, these oil diffusion pumps, big honkers. And backed up by the 4-pump and the roughing pump, just like any high vacuum system. Pardon me. And you could get down to this sort of vacuum, otherwise the thing didn't work. I thought it was a fascinating bit of engineering, really was.
It's impressive that they're sliding the film through this contact material and it didn't scratch it. That's hard for me to imagine.
Well, that's the way it works. On the vacuum thing, and I do not remember the details, as James says, it's been 45 years ago, but I do know US Steel at Fairless Works had a vapor deposition of aluminum onto steel, where they rolled the steel 10 feet wide, 500 feet per minute, off the roll into a vacuum chamber, coated with aluminum, and pulled it out the other side onto a coil. And I know I saw the machine running, but I just don't remember the details of it. So they were able to create a vacuum good enough to do vapor deposition of aluminum.
Yeah, if you can do something that big, you can darn sure do a 16 millimeter piece of film.
Yeah.
You can seal it off well enough. And it did, as I say, it did dry the film to some degree. You could build up a static charge on the film. If you didn't, most of the time we went right into the processor. I guess maybe once in a while they would do a negative rather than a reversal film if they wanted to make some multiple copies. I never got zapped, but I talked to the operators. That's one of the reasons they were gun shy. They had been zapped with this before because the charge built up on the film. But it did. It's a drying process. You're sucking all the air, sucking all the moisture out of the film, which is not good for the film. So that's why the whole thing wasn't at the same vacuum. You did keep the film at a slightly lower vacuum, like say 10 to the -3 versus 10 to the -5 or 6 there where the electron gun was.
Yeah, the steel people didn't have to worry about the static electricity.
No.
For the EVR master, which was recorded by an electron beam recorder, they had a problem that the sensitivity of the film would change during the recording period, apparently because it depended upon the moisture content of the film. So when it was in that cassette being drawn down to the rough vacuum, it would be continuously getting drier and drier, and they had to have an open loop program to change the exposure during a 30-minute period of making the master.
Anybody else have anything left? We pretty much done all we can do to this one. It's what, 10:15. I want to get to bed. I've got a ham radio network early in the morning. I need to get up for and get ready for that. So I'm gonna turn the lights out and call it a night. So thanks for everybody for your attention. Thanks for putting up with my rambling. I hope maybe I've been a little bit entertaining and provided a little bit of information on something which, like I say, is for all intents and purposes the first generation of Kenny. I think I may be one of the last people, not bragging. I don't know who has bragging rights, but I don't think there are many people still standing up that worked around a Kenny machine back in the good old days left. I really haven't run into them.
I'll just add one couple comments. You reminded me of a lot of stuff that I saw at the U of M and the replaceable cathodes. They had those on the Itafor. They had the vacuum pump. They had the diffuser pump, all on the Itafor. And then they had the TFR1 over at the television center.
Yeah.
So you remind me of a whole bunch of stuff from the past.
Well, great technology. And like I say, it hasn't gone away. It's just out in a slightly different form now. But I was really amazed when I found that Celco information. They're still using a CRT to make as a light source. And I've got a feeling this must be a fiber optic faceplate CRT to get what they're claiming out of there. They're claiming this thing is good or better than laser. So I don't know. I would have to see a shootout side by side, but both of the machines, I'm sure, are phenomenal to be able to do HD and UHD prints from electronic, program content, electronic images, and it's all file based too. You're not sending video over a 75 ohm piece of coax. You're sending digital files around on gigabit speed Ethernet to feed these machines. So long, everybody. As I say, thank you for your time. Mine is up. I'll see you again, and stay well.
Thank you much, James.
Thank you.
And thank you for the reprise of Mal Campbell